the Second World War heralded the beginning of the atomic age, but despite the horrific devastation inflicted upon Hiroshima and Nagasaki, there were high hopes for peaceful use of nuclear technology. Compared to coal power stations, the experts said that nuclear plants would offer energy that was abundant, clean, and safe. One day in April 1986 put all that into question. I'm Kari Fay, and this is Great Disasters. Please note that due to the complexity of this subject, this will be a two-part episode. Although America had been the first to detonate an atom bomb, other countries were not too far behind in developing their own nuclear programs. Although initially largely military, they were soon turned to other purposes, and in 1954, the first nuclear power reactor designed for civilian purposes was completed in Obninsk, about 110 kilometers southwest of Moscow. In the then Soviet Union, prominent scientist Valery Legasov wrote, "Specialists are, of course, well aware that it is impossible to produce an actual nuclear explosion at a nuclear power station, and only an improbable concatenation of circumstances could bring about the semblance of such an explosion, which would be no more destructive than an artillery shell." Anatoly Alexandrov, president of the Soviet Academy of Sciences, declared that the design of their nuclear reactors was so stable, so safe, that they could even be installed in Red Square. In practice, of course, they did not choose such prominent locations for their power plants. They looked for places which had a good supply of water, sufficient space which was not of particular agricultural value, and good transport links, and a maximum of 500 to 600 kilometers from consumers. Places like Chernobyl, which stood beside the Pripyat River in Ukraine, not far from the border with Belarus. Construction of the Chernobyl power plant began in 1972, and by 1977 the first reactor was up and running. Unit 2 followed suit the next year, Unit 3 was completed in 1981, and Unit 4 in 1983. A further 2 reactors were planned, and construction of Unit 5 was underway in 1986. For a construction project of this size, that might seem pretty quick, but it wasn't without problems. None of them were completed on time. There were ongoing supply problems, and there was a huge amount of pressure from Soviet authorities to present rapid progress. At the Communist Party Congress in February 1986, the Minister of Energy and Electrification proposed cutting the construction time for nuclear reactors by another 2 years, even though they were rarely able to meet the existing deadlines. This pressure meant that there were some safety aspects that were overlooked while it was being built. The reactors used water as a coolant. It was basically pumped through the reactor, producing steam, which ran the turbines to produce electricity, and taking the excess heat away with it. Those pumps required electricity to run. If there was an emergency which shut down the power grid, the plant had emergency generators to power the pumps. They could start in as little as 15 seconds, but took at least a minute to get up to the speed required to run one main pump. That meant that if there was such an emergency, there would be a gap where the reactor wouldn't be cooled. Even if the reactor was shut down immediately, it would continue to produce heat for some time, so that gap presented a risk. To solve this, it was proposed that they might be able to use the rotational energy from the steam turbine, which would continue to spin for a while because of its momentum, to bridge the gap. But they had to prove that would work. That was the purpose of the test they were preparing for on April the 25th, 1986. Reactor 4 was due to be shut down for regular checks and repairs, and that offered the opportunity to test the steam turbine as they did so. The night shift, working from midnight until 8 a.m, were given the first task, bringing the power level of Reactor 4 down from its nominal full output of 3,200 megawatt thermal to half power at 1,600 megawatt thermal. They did this by inserting the reactor's control rods. These were made of boron, a material which absorbed neutrons. The fission process is caused by neutrons colliding with the uranium in the fuel rods, splitting the atom and producing more neutrons, which would also collide with the uranium in a chain reaction. Inserting control rods therefore acted as a brake, slowing down the reaction because the neutrons were absorbed by the boron instead. The reactor had something like 200 control rods, and operators could insert or withdraw them as needed to get the appropriate amount of control. When the morning shift under Igor Kazachkov took over at 8 a.m. that Friday morning, the reactor was stable in that state, but there were 15 or fewer control rods available that weren't already inserted. Strictly speaking, the reactor wasn't supposed to be kept running like that, but they weren't working strictly to normal instructions because they had to carry out that test. Kazachkov was one of the most experienced shift leaders at the plant, and didn't think that was a serious issue. He was working according to the test program, and besides, didn't have the authority to shut the reactor down himself. That order had to come from his superiors, who needed permission from the power grid inspector. He said later that if he had shut down the reactor himself, he would certainly have been fired. Instead, he got on with the next task in the test program, disabling the emergency water supply to the reactor. It wasn't a quick job. They had to shut the valves of the huge pipes by hand, and it took 2 or 3 men to close each valve. However, they were done by 2 p.m. and expected the shutdown to commence shortly after that. Unfortunately, there had been an incident at another power station, which had caused one of their units to go down unexpectedly. The power grid inspector contacted the Chernobyl plant and told them to keep Reactor 4 running as it was, to ensure that there was enough power flowing through the grid. The test would probably be able to resume in the evening, when demand went down. Since the test was postponed, not cancelled, the emergency water supply was left disabled. 4 o'clock came around and Kazachkov handed over to the leader of the evening shift, Yuri Trihub. He was not happy with the situation. He was not familiar with the program for the steam turbine test, and had other tests to carry out on his shift besides, but didn't really have much choice in the matter. He studied the test program as best as he could whilst he worked on his other tasks, and waited for word to come from the power grid inspector. And waited. The call from the power grid inspector finally came at around 9 p.m, telling them that they would be able to start their shutdown at 10 p.m. Trihub had also, in the meantime, been told not to do anything until Anatoly Dyatlov, the plant's deputy chief engineer, was on hand. He had gone home to rest. A call to Dyatlov's home confirmed that he was on his way back. At around 11 p.m, Dyatlov arrived in the control room. It had taken him longer than expected to get there. According to Trihub, he stopped off at Unit 3 on his way and evidently found something wrong with regard to discipline. He dressed them down. Although Trihub had questions about the test program, Dyatlov apparently declined to answer them. This may not have been quite as dismissive as it sounds. Trihub's shift was due to end at midnight, and Dyatlov had apparently now decided to run the test on the following shift. The power of the reactor was now reduced even further. The test was intended to be carried out with the reactor producing 760 megawatt thermal, and Trihub brought it down to this level before handing over to the leader of the next shift. This was Alexander Akimov. Although he had 10 years' experience at Chernobyl, he had only been appointed to lead the shift 4 months earlier. The senior engineer on that shift, Leonid Toptunov, was also new to his position, just 3 months in. They would have expected a quiet shift that night. The test was supposed to have been completed, and they should have been simply monitoring the reactor as it cooled down. Instead, arriving half an hour before his shift began, Akimov discovered that he would be running a test he knew very little about. Treehub, who by now knew a little more because he'd been studying it throughout his shift, decided to stay on as an observer in order to help if needed. Officially, Akimov was in charge of the control room from the beginning of his shift at midnight. In practice, however, Dyatlov was in control. Razim Davletbeev, the deputy chief of the plant's turbine unit, was also in the control room at this point. He recalled, "Immediately upon the start of the shift, Dyatlov began demanding that the program continue to be carried out. When Akimov sat down to study the program, Dyatlov began reproaching him for working too slowly and failing to pay attention to the complexity of the situation that had arisen in the unit. Dyatlov shouted at Akimov to get up and started insisting that he hurry up. Akimov, holding a sheaf of papers in his hands, evidently the program, began going around to the control room operators and establishing whether the equipment was in appropriate condition for the program that was being carried out. It seems that, at this point, there was some difficulty in maintaining the reactor's power level. It dropped unexpectedly, and Treehub stepped in to help engineer Toptonov bring it back up by withdrawing some of the control rods. They stabilized it at 200 megawatt thermal, considerably lower than the 760 stated by the test program. There was also apparently some debate in the control room. Treehub would later recall that Dyatlov insisted the power be kept at 200 for the test, and others recalled him urging people to hurry up. It was now 43 minutes past midnight on the 26th of April. Dyatlov ordered the operators to block the emergency signal from the 2 steam turbines which would be used in the test. Shortly after 1 o'clock, the 2 reserve water pumps were activated, as dictated by the test program. This increased the flow of water through the reactor. Shortly after that, an alarm told them that the steam pressure was low, and those reserve pumps were switched off again. Water was a very important factor in the reactor. The levels of steam and water had to be balanced very carefully, because as water, it would absorb more neutrons than it would as steam. When the reactor was already running at a very low level, this was tricky. There was another issue with running the reactor at such a low level: the accumulation of a byproduct called xenon-135 in the fuel rods. Like the water and the boron in the control rods, this slowed the reaction down. Toptonov continued to withdraw the control rods so that the reactor would keep running. This continued until there were only 9 control rods inserted. At 1:22, the water in the cooling system reached boiling point. As it turned into steam and was able to absorb fewer neutrons, the reaction rate picked up again. At the same time, Akimov was starting the test. Davletbeev recalled, "Akimov went up to every operator, among them the senior engineer in charge of turbines, Igor Kirschenbaum, whom he briefly instructed that after the command was given to start the test, he should shut off the steam on turbine 8. Then Akimov asked the operators to get ready, after which the test representative of the Dontik Energo enterprise, Metlenko, gave the command, 'Attention, oscillograph, start.' After that command, Kirschenbaum closed the stop valves of the turbine, while I stood next to him and watched the tachometer, monitoring the speed of turbine 8. As was to be expected, its speed fell sharply as a result of the electrodynamic braking of the generator. When the speed of the turbo generator had been reduced to the level specified in the test program, the generator started up again. That is, the coasting down segment of the test program worked properly, and we heard the command of the shift leader Akimov to shut down the reactor, which was done by the operator of the unit's control panel. The test took 36 seconds. Then all hell broke loose. Toptunov shouted that the power level was rising rapidly, and Akimov ordered the shutdown of the reactor using the scram, or emergency shutdown button. This made all the control rods drop into the reactor. They should have absorbed the neutrons and stopped the chain reaction, leaving nothing to do but monitor the reactor as it cooled. Unfortunately, the tips of the control rods were not made of boron. They were made of graphite, which didn't have the same qualities. It was the same material used for the reactor's moderator. It slowed down the neutrons, so that they'd be more likely to hit a uranium nucleus. Between that and the change in water levels caused by the rods dipping into the reactor, it was enough to tip the reaction over the edge. The core temperature jumped up, and the cladding on the fuel rods fractured. The control rods, only 1/3 of the way down, jammed. Power jumped from 200 megawatt thermal to more than 500 in a few seconds, then shot up to more than 30,000, 10 times what it was supposed to produce. What happened next, Davletbeev described as a roar of a completely unfamiliar kind, very low in tone, like a human moan. Trihub remembered multiple shocks, but not as in an earthquake. If you count 10 seconds, there came a roar, and the frequency of the shocks diminished, but their strength increased. Then came the sound of the blast. What they were hearing was an explosion of steam from the reactor, which destroyed its casing and threw the 200-ton concrete plate that formed its upper biological shield into the air through the roof of the building. It landed back on top of the reactor, but not in its original position. It was no longer covering it completely. A couple of seconds later, there was another, louder blast. Davletbeev said, "The floor and walls shook violently. Dust and bits of debris fell from the ceiling. The luminescent lighting went off. Semi-darkness descended, and only emergency lighting was on." Trihub remembered that everyone was in shock. Everyone stood around with long faces. I was very frightened. Complete shock. They had no idea what had just happened. Dyatlov's first guess was that the emergency protection and control system tank had exploded. That was 71 meters or 233 feet up, directly above the control room. However, if that was the case, the control room would quickly have been flooded with hot water. There was no sign of that happening. The control panel showed him that there was no water flow to the reactor. He believed that it was shut down, but it would still need cooling as the fission process wouldn't stop immediately. So he ordered the operators to restart the water pumps and cool the reactor at emergency speed. Their displays also told them that the control rods had stopped about 1/3 of the way down. They knew that meant that they wouldn't be affecting the bottom of the reactor. So first they tried switching off the power to the rod's servos, hoping that they'd fall by gravity. When that didn't work, 2 interns, Viktor Proskuryakov and Alexander Kudryavtsev, were ordered to go to the reactor hall to try and shift them by hand. Davletbeev was one of the first to reach the turbine hall. He described it as a picture worthy of the pen of the great Dante. From somewhere above I could hear the sound of escaping steam, although neither steam nor smoke nor fire was visible in the broken spaces of the roof. What could be seen instead were the stars shining brightly in the night sky. Streams of hot water were bursting in every direction from the damaged pipes and falling on the electrical equipment. There was steam everywhere, and the crackling sounds of short circuits in the electrical system resounded as sharply as gunshots. Engineer Vladimir Shashanok was brought to the control room. He had been on level 24 of the unit when the explosion occurred. Dyatlov recalled, Volodya sat in a chair, just weakly moving his eyes, neither groaning nor crying out. Evidently, the pain had exceeded any conceivable level and rendered him unconscious. He had been found pinned under a beam. He had suffered a broken spine and broken ribs, as well as deep thermal and radiation burns. He was taken to the medical station. One of the men who carried him there got a radiation burn on his back where Shashanok's hand had been. The wounded man would die later that day without regaining consciousness. Yuri Trehub and another operator from his shift, Sergei Gazin, were sent to open the gate valves of the cooling system manually, but were beaten back by hot steam. They went back to the control room. So did the two interns, Proskuryakov and Kudryavtsev. They hadn't been able to reach the reactor hall. The elevator was jammed, and the stairwells were full of debris and steam bursting out of pipes. They got as close as they could before giving up. Dyatlov dismissed some of the non-essential staff in the control room and prioritized actions that would prevent the disaster from spreading to the other reactors, including the shutdown of Unit 3. At around 4 a.m., he was summoned to report to the plant's director. He was, by then, pale and nauseous, and soon after was in an ambulance on the way to the hospital. Outside, firefighters had responded quickly. They did not wait for a call, as they had seen the explosion from the fire department building. They were on the scene within 5 minutes of the explosion, and could immediately see that it was serious. Lieutenant Volodymyr Pravik radioed for assistance, sending the highest level of alert which would call all firefighting units in the Kiev region into action. However, they didn't know what exactly was wrong. 2 technicians they saw running from Unit 4 suggested that the fire was on the roof of the turbine hall. Because that connected all 4 reactors, that would be very serious indeed, so that was where they headed. Firefighters Leonid Chavray and Vladimir Prishepa climbed up a ladder to the roof of the turbine hall. Prishepa later said, "I saw that parts of the ceiling were damaged, and some had fallen. Closer to the edge of the roof of Unit 4, I saw the spot where the ceiling had started to burn. I wanted to approach it to put out the fire, but the ceiling was shaking." Chavray remembered their attempts to extinguish the fire without using water because of the electrics inside. "We tried to beat out the flames with canvas fire hoses. There were water pipes for fighting fires on the roof and hoses in containers, so we used those hoses to fight the fire. There were holes in the roof, and once we started pouring water, there might be short circuits. We beat the flames with the hoses and stamped on them with our feet. It was hard to walk, as the bitumen on the roof had melted. Such heat! With the slightest increase of temperature, the bitumen immediately caught fire. If you stepped on it, you couldn't put one foot in front of the other. It tore off your boots. And the whole roof was littered with luminous, silvery pieces of debris of some kind. We kicked them aside. One moment they just seemed to lie there. The next moment, they would catch fire. The heat on the roof was so intense that they found it difficult to work in their standard gear. They took off their helmets and unbuttoned their jackets so they could breathe more easily. Meanwhile, more firefighters arrived. Because Chavray and Prishepa's team were already handling the roof of the turbine hall, the next team turned their attention to the roof of Unit 3. This stood very close to Unit 4, sharing some of its facilities to save money, and was now on fire. They hooked up hoses to the water pipes and climbed up 72 metres, 236 feet, to the roof. Whilst some directed water at the flames, others kicked bits of hot debris off the roof before it could start new fires. They didn't know that debris was highly irradiated. At about 2:25 a.m., the team from the roof of Unit 3 descended. This included Pravik, Lieutenant Viktor Kibanok, and Vasil Inatenko. They were, according to Major Leonid Telyatnikov, head of the fire department, in very bad shape. They had only spent about half an hour on the roof, but they all felt sick. Valentin Bilokon, the only doctor on duty that night, had arrived at the plant expecting to treat burns, but instead saw cases of nausea and excruciating headaches. He wondered at first if the victims had been drinking. It was, after all, Friday night. But once he saw the firefighters, he realized it was much more serious. He called his superiors and asked for them to send supplies of potassium iodide. Still more firefighters arrived. Petrus Chavray was one of them. He was the younger brother of Leonid Chavray, who was atop the turbine hall, and their other brother Ivan was on top of Unit 3. As he arrived, not fully geared up, he heard Leonid shouting for hoses. I immediately took off my shoes and put on kersey boots, throwing my cap into the car. I put 2 hoses under my arms and climbed the ladder to the top. And that was all the protective gear I had, just my boots. Protection didn't matter. Minutes counted to stop the flames from spreading. The electricity that was supposed to supply the water, however, was cut off. They decided to use the water from the plant's cooling pond instead. Getting the truck there was difficult as there was so much debris in the way. Petrus Chavray recalled taking metal rods out of the wheels with his hands and kicking them out with his feet. Only when the skin on his hands peeled off did he realize that the rods were radioactive. Still, he got the truck to the pond, and the water brought the fire under control. By the time they were allowed to leave their posts, near to 7 a.m., all 3 Chavray brothers felt ill. Petrus said, "I was retching and felt terribly weak. My legs wouldn't respond, as if they were made of cotton." He was so desperately thirsty that he took a couple of sips of water from the hose. But the water was radioactive. I knew that, but it seemed to me that if I didn't get a couple of swallows, I would fall and wouldn't be able to get up. Viktor Bryukhanov, the director of the Chernobyl power plant, was awakened by a call at 2 a.m. and went straight to the plant. He initially had trouble finding out what had happened, but when he saw that the building next to Unit 4's reactor hall was in ruins, he knew that it was bad. A special bunker, designed for use during a nuclear war or emergency, was opened as a command post, and he ordered the managers of the plant to report to him there. Anatoly Sitnikov, another deputy chief engineer at the plant, and Vladimir Chuganov, the chief of Unit 1, were sent to inspect Unit 4, assess the situation, and make sure that the emergency cooling system was on. Sitnikov climbed up to the roof of the reactor hall and looked in. It seems that he was unable to believe what he saw, because he carried on as ordered, trying to open valves to send water in to cool a reactor which had already been destroyed. The 2 managers couldn't do this by themselves, so Chuganov went back for help. When he returned, he found Sitnikov with his head on a desk, overcome by nausea. The 3 engineers he'd brought with him, alongside Akimov and Toptunov, went to open the valves. On his arrival, Viktor Smagin, leader of the morning shift, described Akimov and Toptunov as looking extremely depressed, with swollen dark brown faces and hands. Their lips and tongues were so swollen that they could hardly talk. Their shift finally over, they were able to take an ambulance to the hospital. As morning dawned, it seems that still nobody had truly grasped the extent of the disaster. Engineer Arkady Uskov recalled telling the shift's deputy chief engineer Mikhail Lyotov about the radioactive graphite littering the area around Unit 4. It had obviously come from inside the reactor, where it was used to moderate the reaction. Lyotov refused to believe that. In his diary that day, Uskov wrote, "The mind refuses to believe that the worst that could happen has happened." In the bunker, Bryukhanov and his colleagues put together the first official statement. They said that the roof of Unit 4 had collapsed and that the radiation levels were 1,000 microroentgens per second at the plant and 2 to 4 microroentgens per second in the city. Please note that roentgens are an outdated unit for measuring radiation exposure, but I'm using them because that's what the Soviet authorities at the time used. For reference, the first formal dose limit for radiation exposure was established in 1931 by the American National Council on Radiation Protection and Measurements, and it was set at 0.1 roentgens per day. At the lower estimate the memo gave for the city of Pripyat, they were already exceeding that dose. Of course, Soviet authorities didn't abide by American regulations. Besides which, the figures they were giving were just a guess. There was only one dosimeter at the plant which could register anything higher than 1,000 microroentgens per second, or 3.6 roentgens per hour. That had registered off its scale beside Unit 4, indicating a level of more than 200 roentgens per hour, and Bryukhanov had ignored the man who had it. 200 roentgens an hour would mean that they were exceeding that 0.1 per day limit in less than 2 minutes. The Soviet threshold for civilian evacuation of a contaminated area, an accumulated dose of 75 roentgens, would take less than half an hour. Despite all this, at a Pripyat Party committee meeting held at 11 a.m. on Saturday morning, the official line was that radiation levels were too low for any drastic action. However, over the course of that day, 132 people were sent to hospital with signs of acute radiation poisoning. Word reached the very top levels of the Soviet hierarchy at about 5 a.m. on the morning of Saturday the 26th of April, about 3.5 hours after the explosion, with a call to Mikhail Gorbachev. At this point, he was told that the reactor was still intact, and again, there was no need to take any drastic action. He simply ordered a state commission to be appointed to look into the causes and consequences of the explosion. The commission was chaired by Boris Sherbina, deputy chairman of the Council of Ministers in charge of the energy sector, and included Anatoly Mayarets, Minister of Energy, his deputy Gennady Shasharin, as well as a number of other experts. They flew to Kiev that day, and from there went on to Pripyat and to the power plant itself. The Central Committee's top nuclear expert, Vladimir Marin, was also included. On the way, he seemed quite cheered by the news coming out of the power plant. Amazingly, there is no contamination, he's said to have told another member of the party. It's a really terrific reactor. When they arrived, they were surprised to find themselves greeted by Vasil Kuzima, director of plant construction, rather than the plant's managers. Of course, by then, Director Bryukhanov was already quite ill. Kizuma took Marin and Shasharin to the damaged reactor, and they were shocked by what they saw. Shasharin remembered Kizuma jumping out and, without the slightest fear, walking about looking very much in charge, and lamenting the fact that after all the effort that had gone into building the place, now they were walking around among the wreckage of the fruits of their labour. Marin recalled kicking a bit of debris in rage and frustration. Only later did he realise that it was a block of graphite, probably producing 2,000 roentgens per hour. They were affected quickly. Shasharin recalled that they had difficulty breathing. Our eyes smarted, we were coughing severely, and deep inside we felt extremely worried and vaguely anxious to get out of there and go somewhere else. They joined the plant's managers in the bunker, where still nobody was ready to consider the possibility that the reactor itself had exploded. Despite feeling the effects of the radiation, Shasharin and Marin didn't think it was that bad either. The first meeting between the Moscow experts and the local officials began. Mayarets was apparently still under the impression that they would be able to fix the problem and reconnect Chernobyl to the power grid within a few days. Shasharin spoke reassuringly of the actions underway. Cooling water was being pumped into the reactor, and boric acid was to be delivered to help stop the fire. Marin asked directly where the graphite lying around on the ground had come from. Bryukhanov, who was said to have an ashen face and puffed up eyes, was quite plain about it, without actually saying the words everyone dreaded. It's hard to imagine. The graphite we received for the new number 5 unit is all there intact. I originally thought it must be that graphite, but it's all there. In that case, it might have been ejected from the reactor. The obvious logic that this could only have happened if the reactor had exploded was apparently still overlooked at this time. Vladimir Shishkin, a ministry official at the meeting, commented that it seemed that all those responsible for the disaster were anxious to delay as long as possible the awful moment of reckoning, when the truth would be disclosed in every detail. There were only a few dissonant voices. General Hennady Berdov, Ukrainian Deputy Minister of the Interior, informed the Commission that 1,100 buses had been mobilized and were on the way to Pripyat in case the city needed to be evacuated. Mayorets was astounded, asking if the general was trying to start a panic. Bryukhanov's civil defense chief, Seravim Vorobev, the man with the only high-level dosimeter available, also demanded evacuation, pointing out that the radiation was exceeding the limits they could detect. Mayorets wanted to speak with the operators who had been involved, but they were all in hospital, their skins brown with radiation tans. It was only when 2 further experts from Moscow showed up that this atmosphere of denial began to change. Boris Prushinsky was the chief engineer of the Department of Nuclear Power Stations, and Konstantin Polushkin was a senior academic at the institute which had designed the reactors at Chernobyl. Their arrival had been delayed because, after arriving in Pripyat, they had found a helicopter to fly them over the station. They'd actually looked at the situation from above. They told the Commission that the central hall of the main reactor building was gone, as were the main circulation pump room and the steam separator room. Prushinsky said, the upper biological shield of the reactor was now a bright cherry red from the extreme heat, and was lying at an angle over the reactor vault. It was safe to say that the reactor was utterly finished. When asked what could be done now, Prushinsky replied, God knows. This story will continue in the next episode. This episode of Great Disasters was written, researched and produced by me, Kari Faye. However, I couldn't do it without the support of you, the listeners, and Patreon followers like Andy S.J., Michael Faye and Skeleheron. You can help the show by going to patreon.com/greatdisasters, by telling your friends, or by reviewing the show on your preferred platform. I'd also love it if you stop by the show's Facebook page, that's facebook.com/greatdisasterspodcast, to say hello. You can also find us on Instagram and Twitter. You can also check out the website greatdisasters.co.uk for transcripts, past episodes, and more. Thanks for listening, and please do stay safe.